Okay, here we are. Okay, Bente, the floor is yours. I will stop sharing my screen and you can go ahead.
Yes, thank you. So welcome to this session where we are going to present the results of what we have called the Dubrovnik Inspire Hackathon. My name is Bente Liljaby. I'm representing Plan for All and will be one of your hosts today, I would say. We have quite a bit of a program because in this Inspire Hackathon, which has been virtual as well as now the finals and awards, as we call this event, has all been virtual. But normally that's also how we are running the hackathon itself. It's a virtual hackathon. It's this one here is, I think, well, the first Inspire hackathon took place in Barcelona at the Inspire conference in 2016. So we are very excited to be here. I will be as short as I can, because we have 12 challenges and teams that will present their results. Before I will show you the program, so you get a little bit feeling of what you actually will be learning about today. I will introduce the program. Hanka, can you share your screen where we have an introduction to the content of this session? Yes, here I am. I see. So we are on our way.
So can you see my screen?
Yes. So we have 12 challenges that you will learn more about. Each of the challenges will present the results in 5 minutes, so quite a short time. The jury, and I will introduce very quickly the jury shortly. The jury will be able to ask a question. Unfortunately, we don't have time for you, the rest of the audience, to ask questions, but the jury will. And after that, after all the 12 presentations have been done, we will ask not only the jury to evaluate everything, but we will ask you, the audience, also to evaluate and score the top 3 teams. You will get information about that when the jury retire to do their consultation. So just follow on, keep an eye here all the time, and you will be able to be to scoring your favorite result today. So as you see, what do we have to offer? We have 12 challenges, and several of them are dedicated or addressing citizen science. Of course, the common denominator is Inspire, making data and information interoperable. We promote the use of Earth observations, Copernicus and GEO. So that's the common thread throughout. But this year we have 4 challenges addressing citizen science. And secondly, we have also artificial intelligence. This is a new technology that has a great potential for applications in sustainable development goals in particular. And we have a series of challenges that also addresses food security in particular. So EO for Agri is one of the sponsors or supporters. We Observe is another key sponsor for the citizen science. I forgot to mention that. And then finally, we have general interoperability frameworks and open data, and we address traffic and also open land use, so the use of land. All of these, so the second ones are, a component in several of the SDGs. So that's the exciting content we will learn about today. I think we are ready to start. Did I forget anything? Yes, I did, because I want you to learn about the jury. So the jury, Jitka, can you say hello to the audience?
So it's the microphone, here's the camera. So good morning, my name is Jitka Frognerova. I've been working in the Czech Environmental Agency for last 11, 12 years, and I'm kind of a national coordinator and a person responsible for the Inspire implementation in the Czech Republic. I work with my team on basically all the aspects you have been mentioning: data interoperability, making data available, setting our national Inspire infrastructure, connecting it to the European infrastructure, and so. These are the aspects I know, so I'm happy you have invited me for being the jury, and I'm really interested in the projects I'll be seeing.
Yeah, thank you, Jitka. And this is the second time you serve as a jury member for us, if I'm not mistaken. Yes. And Alexander, you are a newcomer in the jury. Let's learn about you.
Good morning, Bent. I hope that you can hear and see me. Hi to all. Alexander, indeed, the newcomer in this hackathon. Thanks for having me. I've been working at the JRC, European Commission, at the Inspire team for the past 7 years. My work there is dedicated to the technical aspects, exchanging information, standards, technologies, and so on, also helping member states in the implementation. Apart from that, I've been dealing with citizen science, sensor data, and now I think after having already familiarized myself with all the exciting applications and the 12 challenges, I'm already impressed by the diversity of the topics. I use the opportunity to wish all the teams good luck, fingers crossed. I'll be listening carefully and asking questions every now and then. Thank you.
Thank you, Alexander, and welcome to this community. Now, finally, but not least, Stefano.
Good morning. I'm Stefano Tomascelli. I'm an expert in video game industry, and I work in a lot of European projects. And it's not my best expertise, but I work in artificial intelligence field in a lot of projects. Finger crossed, and good luck to all the team.
Thank you. Thank you. Lovely to have you on board. So Thomas and Hanka are sort of in the background here. A quick word from you. Thomas and Hanka are both working in Plan for All. Thomas, let's hear from you. You will be the time taker because we need to be very strict with the time.
Yes, thank you. My name is Tomáš Meldorf. I'm the chairman of Plan for All. I'm also an employee at the University of West Bohemia in Pilsen in the Czech Republic. And as Bente said, I will be keeping the time, so I will make sure that all the presentations are within 5 minutes limit. So, yeah.
Yes, thank you, Thomas.
Over to you, Hanka.
Yeah, Hanka.
Hello everyone, I am Hanna Kubíčková and I will take care of your presentations and show your slides. And I am employee at Plan for All. I work as a project management support and I will be also the one who will be presenting one of the challenges.
Yes, excellent. So let's dive into it. We go by the number. So the number 1, the challenge number 1. Are you ready to do the presentation? Hanka will share her screen. I will turn off my camera as well. Is it Jana that will be the presenters as far as I think I know? And Jana is here.
Hello, everyone.
Yes.
Hello. You heard me?
Hello, Jana. We hear and see you.
Yeah, okay. Fine. Okay, let's start. Hello, everyone. My name is Jana Saidlova. I would like to introduce to you my team, my colleague Iva Batlova and our mentor Jiří Kvapil. Next slide, please. Anna? Hello?
It looks...
Hanka, we can't see the presentation. Oh, we can see just the PowerPoint.
Oh, okay.
Okay.
Thank you. Our challenge is challenge number 1, using Sentinel-1 data and IoT technology for an analysis of soil moisture. Next slide, please. Thank you. We were using data from Sentinel-2, Sentinel-1, ascending, descending, and ground measurements of soil moisture. All data were from year 2016 into growing season. Our area of interest was Rstenice Zvonovice, located in the South Moravian region in Czechia. Next slide, please. We used open source software, Jupyter, Snap, and QGIS. In the corner, you can see the most used libraries in our project. Next slide, please. First step in our methodology was data download and processing. Sentinel-1 data we preprocessed in Snap software using various steps, including calibration or terrain correction, and then substitute into small images due to space saving. 61 spectral indices from Sentinel-2 data were computed using Python script and compared with preprocessed Sentinel-1 radar data. Pearson correlation coefficient was computed between each radar data value and every one of spectral indices. Pearson correlation was also computed between radar data and ground measurements of volumetric water content. Linear regression equation was applied between ground measurements of volumetric water content and Sentinel-1 VV polarization, VH polarization, and well as local incident angle. Next slide, please. Now it's time for the results. In right corner, there is a graph of correlation between Sentinel-1 data and ground measurements of 5 different satellite images. The darkest color represents the strongest correlation. You can see that the more vegetation there for this time, the more the radar vegetation correlated with volumetric water content values. In the bottom, there is a graph of correlation between Sentinel-2 and Sentinel-1 data. Height correlation were found between VH polarization and soil indices. Next slide, please. Linear regression between radar VH polarization, which was a most promising, and volumetric water content doesn't not much of correlation between two datasets. Next slide, please. Overall results were not as successful as expected, but it may be due to lack of data in the selected year. We were trying every possible combination with our data to understand more deeply the relationships between them. Thanks to those analyses, we have greatly improved our knowledge of radar data. The research will, yes, thank you. The research will continue and more analyses will be computed for another years, and datasets will be expanded to gather more information. Focusing on spectral indices with the highest correlation will be another part of ongoing project, as well as trying on compute and test more radar indexes. Next slide, please. Thank you for your attention.
Thank you, Jana. Thank you very much. Now, jury members, do you have any questions for Jana? No questions for
I have
Jana?
one.
Yes.
This is Alex speaking. First of all, thanks, Jana, for the interesting presentation. I was wondering also after reading the overview of your challenge, whether you did investigate the quality of your in situ data. Because I think for the Sentinel, it is absolutely clear, it is well documented, well established, there is a substantial body of literature out there. But I was just wondering, when you do the data processing and the data analysis, I think it would be important to look into also the quality. What are the data from your sensors like, and what are the issues possibly there?
Yes, thank you. We don't know. We have only this data and this. We didn't test it.
So probably something to be considered in the future. Thank you.
Thank you.
Yeah, thank you. We can then move on to the next presentation, which is challenge 2, and that is Hanna Kubikova who will do that presentation. And I think you need, Hanka, can you put your presentation in presentation mode as well?
Yes, but there were some problems with it when I was presenting Jana's presentation. Can you see the slide?
Now it's okay. Yes.
Perfect. So hello everyone, my name is Hanna Kubíčková and I'm going to present you the results of challenge 2, which is dedicated to using machine learning for detection of land use objects. First of all, I would like to briefly describe you the motivation of this challenge and the reason why we decided to detect field boundaries. Actually, this motivation lies in the fact that if we have available the accurate information on field boundaries, it means its spatial extent and location, then we have a valuable input for many agricultural applications like crop monitoring, yield prediction, food security, crop management, and many more. In the Czech Republic and other European countries, this spatial information is stored and constantly updated in the land register called Land Parcel Identification System. However, if we want to use this information as an input for precision agriculture and, for example, calculate yield prediction, we will encounter a major problem. This occurs when several types of crops are grown on the same field, and we are sometimes missing the boundaries of individual crop types, as you can see on this slide. So our main goal was therefore to find possible machine learning algorithms that can be used for field boundaries detection from Sentinel-2 or Landsat images and make this process of updating crop boundaries easier. On this slide, you can see the methodology of the concept. For training the model, we need some training data. In this case, it was 12 bands of Sentinel-2, and then also some training field boundaries, which were from South Moravian region in the Czech Republic. Firstly, the great part of the challenge was dedicated to data preprocessing to be conveniently used for machine learning algorithms. Sentinel-2 data needed to be aligned correctly with their corresponding shapefile of fields. This shapefile was further converted to binary image, where black color represented borders and white color represented field class. The next step was to clean up data because a lot of images within the area of interest contained erroneous data. Either some bands of Sentinel-2 images were missing or shapefile didn't contain any parcels at specific locations. So these data were detected and filtered out before further processing. Unfortunately, this step caused loss of big portions of area, which was a little bit unpleasant for us because for machine learning model training, it's crucial to have as much data as possible. The possible way how to deal with this problem was using augmentation that extended the number of training data in our dataset by modification of existing tiles, for example, by rotating, flipping, cropping, skewing tiles, and shifting contrast, which generated brand new tiles. For field boundary detection itself, we use deep neural network with modified unit architecture capable to automatically extract useful data from Sentinel-2 image bands. Unit architecture was used for semantic segmentation, where on input is typically an image. In this modified example, a 12-layer tensor, and on output, it returns a matrix with assigned prediction of classes for each individual pixel. In this case, only 2 classes. Now, let's move to the results of the challenge. The trained model was able to predict most of the tiles from the test subset that was close to ground truth masks. However, on some tiles, the trained model failed by filling whole mask by either black or white color.
1 minute left.
So we believe the model accuracy suffer by insufficient training data caused by filtering a vast amount of tiles in pre-processing step, and accuracy could be highly increased by adding more locations and data. So the final goal was to obtain shapefile from model prediction. We used Python libraries Fiona and Shapely for this step, and the implementation brought usable output. So as mentioned before, the key element for further improvement of model accuracy is that we can to add more training data and retrain the model. Then we can also use multi-temporal Sentinel-2 images. Now for this test, we used only 3 seasons or three months for training the model. And also we could choose better combination of satellite bands. So thank you very much for your attention, and I am ready to answer your questions.
Thank you very much, Hanka. And I give the floor again to the jury. Do you have a question for Hanka here?
No, not for the moment.
All crystal clear. Okay. Thank you, Hanka. You can go back to sharing your the screens to the other participants. We have a number 3, which is Andre, I think, who will yes introduce deep learning for weather forecast.
So
Just a moment, please.
Yes,
All right.
yes, of course. Okay.
Can you
All
see
right.
the full? No, full screen is not available in this mode.
It looks
Okay,
like full screen.
let's have it right like this.
Yes.
Yeah, all right. So hello everyone. My name is Ondřej Kaas, and in the following couple of minutes, I'm gonna present results of our group in deep learning for weather forecast. Next slide, please. The goal of the challenge was to adopt the deep learning methods for local weather forecasting in the field, combining the data from sensors in the field and the global open source historical data from same area. Because the data comes from a different sources, we had to create the one comprehended dataset, which contains the cleaned dataset from some measured errors, correct time matching to don't break the time series continuum, and also removing the unwanted measured phenomenons. Then we move to next step, training deep neural network itself. So let's have a look at our data precisely. Yeah, and now it's come. Next slide. So we had the data from sensors located in 2 fields from 2016 to 2018, which measured phenomenons approximately every 2 hours. Among the measured phenomena belongs the air temperature, weather potential, conductivity, and others. So next slide. The second bundle of our dataset comes from ERA 5, which we picked up the same year as our sensors and also the closest provided measured squares. Next slide. Then we started experimented with long short-term memory or short LSTM. And this is the recurrent artificial neural network, and it's widely used for time series prediction. And at the beginning of our experience, we manually tested the hyperparameters of the neural network to see if it can provide some promising results. We choose the mean square error as the validation metric along with ADEM optimizer. All right, next slide. All right, let's see our results. When we finally finish our datasets with cleaning some error observation and something like that, there was 282 and 12 hours observation for training. We divided it into two chunks. The first 80% we used for training our neural network, and the rest 20% used for testing. Quick math shows that we are predicting for 50 days and 60 hours. And at the first look, we took the air temperature as a prediction phenomena. And as you can see in right side image, where the blue line is actual training set, and the red one is the prediction from our neural network for that 50 days. It comes very well, but we see some caveats. But the mean square errors was under the half of Celsius. So next slide, please. Next, we move to another phenomenon, the air relative humidity. The prediction interval was the same as the previous scenario, with also promising results.
1 minute left.
Yeah, next slide. But as always, there are some problems. As you can see in the water potential phenomenon in the image on the right side, the neural network prediction is definitely copying the trend, but they suffer from some biased problem. So our future steps leads to creating the ensemble of LSTM, where the neural network with different hyperparameters will be trained at the same time in parallel, and then the result will be combination of the top best prediction, and this can avoid the bias problem. And also, the second step will be deploying the whole pipeline into our production to be faced with the real and current prediction in nowadays. So thank you for attention, and waiting for questions.
Thank you very much, Andre. And again, the jury, do you have a question for Andre?
I can ask one if I may again. This is Alexander speaking.
Absolutely, go ahead.
Thanks, Bente. Thanks a lot for the interesting presentation. I was wondering whether you did test other machine learning techniques and compare to the neural network, and what was the result if you did so. Thank you.
Actually, we tried to also the AR, which is, ARIMA, which is the widely used statistical framework in nowadays. And the problem was that the LSTM brings more, in some cases it's more precisely, but the caveats, as we can saw on previous slide, the problem with bias problem. So LSTM has some problems, but it can lead to better accuracy as the other statistical methods.
Clear. Thank you for the answer. Thanks.
Thank you. And now we are switching gear. We are going to the traffic modeling. And Daniel, are you here with us?
I don't know, am I? Can you hear me?
Yes.
Okay, perfect. Can I actually, I can see that Hannah is sharing her screen, but actually I have a video that is in the presentation. I don't know if it's in the version that Hannah is using. Can I maybe try to share my screen? I think we tried last week, last time was Hackathon and it worked perfectly.
Yes, you can, Daniel.
Okay, I should be sharing it right now. Please
Yes.
tell me if it's
Yes.
working.
Yes.
We can see it.
Okay, I should be probably switching off my video. I don't see that. But if it's okay for the video stream, then I can continue just like that.
Yep, go ahead.
Okay, perfect. Let me start my stopwatch as well. Okay, so traffic modeling from web browser use case of Františko Vylázně. At first, I'd like to stop for just a few seconds to tell you what traffic modeler is. This is a 5-year-old idea that server-based traffic modeling should be possible. So you, as a city employee, you wouldn't rely on a desktop solution to model traffic. And we've been trying to develop such a solution for the, like I said, past 5 years. And the basic idea is that you have some default traffic model. You want to know what will happen if you put a stop sign right here, or if you want to close the road. And you want to know what will happen in just a couple of seconds. We are furthest with development in the Pilsen city and the Flanders in Belgium. Again, just a few seconds about the traffic modeling and what data do you need for it. You need some sort of a network, and you need also some traffic generators. You can imagine this as points that generate demand for people to go to and or come from. You use that to create something called origin destination matrix, and then you recalculate that traffic throughout the network so that people find the optimal path. And ideally, you then do the calibration if you have some real world data. Now to what actually we did for the hackathon. So as with any other modeling, the most important part is the data itself, and it's not always easy to come to those data and have them reliably available to you. So we wanted to test what how easy or difficult for us is to use traffic data that already exists, because most cities have some sort of a default or basic traffic model. Some cities have very complicated traffic models, some rudimentary, but they don't always have updated geometry of the network. So we used OSM traffic data from OpenStreetMap, and we combined them with traffic data from company Edip for the in case of Františko Vylázně, which is a mid-sized city in Czechia. We use that because Edip company is working with that city, and they are interested possibly in the traffic modeler solution. So for that, we needed to connect the geometry from OSM with the traffic generators from Františko Vylázně from Edip company, which was done in QGIS in live connected to a Tremor database. Of course, so for some cases, it was very simple. You just connect it to the right node, and sometimes you have to split it between several road segments because you, for example, have a traffic generator that generates traffic for a whole neighborhood, but that is the granularity is not ideal, so you want to split the traffic generator in between several road segments. You can then the model was actually tuned using some additional data sources, for example, like Street View from Google Maps. So the students that helped us with the hackathon were going on looking at Street View and actually changing the parameters of the model, updating it with new information as one-way streets or restricted turns, turn restrictions at traffic stops. because that information is not present in OSM always or not always 100% correctly. Once that was all done, we had a traffic model, and we could develop the traffic model web application, which is something that we've done several times, and that's not the bottleneck of our process. Right now, I would like to show you a quick video of it is just I think 40 seconds. So here you can see in a web browser, you can test it yourself. If you click on this link, the committee should have this link in the final report. And right now you're seeing that in the web browser, I'm closing a highway near Františko Vilazne. I'm setting it. Yeah, thank you. I'm setting a date for the closure. I'm saving the model, and right now you can see the difference between the default model and the experiment that we just did. I think that for the video, I also added one more closure. So I also closed the road near the highway. And again, it should take only a couple of seconds, and we should be able to see again the change traffic. Okay, so we can see once more the difference. This is a very simple model, just done for the hackathon. We are much further with the Pilsen pilot, but this is the idea. So what is next? The model will serve as a playground for testing newly developed algorithms for traffic modeler. It will be a showcase for us during the Polyvisu project for a TriMod webinar that we are planning, and the EDIP company will use it for showing traffic modeler actually as a tool that could be used in Františko Vilazne as part of the data-driven policy in that city. That is all from my side. Thank you for your time.
Thank you very much, Daniel. And do the jury members have questions for Daniel? No, doesn't hear. I don't hear any. Just for your information, there's a chat here, and I have provided some links to more information about the Inspire hackathons. And I just wanted to use this traffic challenge here as one example of the fact that the Inspire hackathons are not an event or events. It's a series, it's a process, and the traffic challenge here is based on former challenges. So it's possible to continue to develop your applications or your analysis over several Inspire hackathons. Just
sorry, Stefano speaking. A question. After this hackathon, what is your idea for the sustainability of the project? In the next step of the project?
You mean the use case of Františko Vilazne or traffic modeler in general?
No, in general, for continue your project.
Yeah. So far, thank you for the question. So far, we are part of several ongoing projects that are the source of funding for traffic modeler. The example being Polyvisu, Horizon 2020 project, and Duet Digital Twin, another Horizon 2020 project. And we are in the past, I think 2 years or 3 years back, we were able to sell to the city of Pilsen for 1 year's time this software as a service. Was a previous version of Traffic Modeler, and right now we are in contact with the city of Pilsen again. They are testing the solution, and hopefully we'll be able to sell it for another year. I'm not sure about that yet, but that's the idea. So far the main source of funding is European projects concerned with data-driven policy. Hopefully in the future, the funding will come from the cities directly.
Thanks.
Thank you.
Excellent. Thank you very much. Yes?
Do we have time for another question?
I
do.
Think, yeah, very quickly.
It's a quick one indeed. Daniel, you mentioned you start from OSM as your input data. Do you contribute some of it back after having done the processing? Because I think this would be important for also the OSM community to benefit from your nice work.
Yeah. That's the idea. Yeah. Once we are sure that again, we don't want to just put something back. We want to make sure that it actually is correct. But that's the idea. You can actually see that we are thinking that way. During Open Transport Network was a project that came before Polyvisu. We created something called Open Transport Map, which is publicly accessible, calculated traffic for whole Europe. Of course, this is not something that is dynamic. This is a static model. But it would be great to actually be able to put the data back to OSM once we know that it is correct, and that we're not just putting something that we think is correct back.
Totally agree. Thanks.
Thank you. Thank you very much, Daniel. And we call upon Dimitri for the challenge number 5. Extend open land use by selected Inspire data theme.
Hello,
Can you see the full screen? Sorry, can you see the full screen right now?
Yes.
Perfect.
Can you hear me?
Yes, Dima, go ahead.
Okay, my name is Dimitri Kozhuk, and here I will present you the result of our challenge, which was to try to extend open land use map by some Inspire data theme. And like next slide, please. Basically, it all started when it was announced that the Kampala and Dubrovnik challenge, Dubrovnik hackathons will be held. I got some email. Some person said that he wants to extend the elements of open land use by the geohazard Inspire theme, but unfortunately, this person didn't do anything. So basically, from my side, I tried to elaborate on conceptually how to in future make systematic integration of Inspire themes into open land use. So this basically was the aim, and it is sort of conceptual framework, and we will try to follow it right now. And now in pseudocode, I will try to explain you how it is done. Next slide, please. So basically, in the beginning, some data storage with all master logic instantiated, and then there is some database like free databases instantiated. Then let's say let's take some example of Inspire theme, for example, Inspire soil theme. So we instantiate object of Inspire soil theme, and the parameters are the name of the theme, the abstract of the theme, URI of the theme from Inspire page, and some directive, some specifications. So this is the input for this object, and then we insert this theme into the database, in the master database, in the list of the themes that are there. And then let's say we want to don't go to the next slide, please. So then we let's say take some data source from open land user, like many data sources that we use. Let's say it's check LPs. So we have we start with Inspire XML metadata for check LPs. Then based on this XML, where everything about this data source is described, we create data source object. We write it to master database. So then from this metadata and from this data source, we create something that could be called the geoconcept. It's basically some accumulated information about the data model and the metadata for the data source. Then basically for this LPs, we create a working directory where we will download the data, which is basically described in the linkage in XML. Then we set the table in the free available database that was created in the beginning. And then after this, because very often the data sources that we use in open land use are cadastral databases, LPs databases, which are very huge. So very often it makes sense to structure structured database by administrative units, or sometimes by some time period. So in this time, let's say we structure it by NATS units. So in parallel with this LPS object, we have also GeoConcept administrative units, which is created in the same fashion. And on this LPS table that is created, we set the inheritance by NATS units. Then based on this metadata and data model, we generate download script, upload script, and update script for this check LPS to run regularly. Then we set for this LPS relevant topics from Inspire. Let's say it can be Inspire land use topic, Inspire land cover topic, Inspire soil topic, and so on. Basically, all Inspire topics to which this data source can be relevant. Then, as I said, in parallel, we have this GeoConcept of administrative territorial units. Then it can be land parcels. Then it can be also soil GeoConcept that is created, let's say, from GRC vector soil database. Then we work in the context of Inspire SIM. So we have Inspire soil team, and we set basically the base layers order from which geometry will be taken accordingly to basically to the meaning of this topic. So here, let's say we put the priority to LPS because on the same land block typically it's just one soil type. Then it's a land parcel. Then it can be other units, but this is the order. Then we set for the Inspire topic the attribute layer from which attribute will be taken by typically by intersection. It can be this soil concept, which is read from GRC database, and then user asks.
Time is up.
The last sentence. So then the user can ask either generate us the whole SIM for the whole Europe. In this case, the separate database will be created, or he can say generated this topic for certain municipality, and then we just need to create view and send the data to the user. So it's just some theoretical exploitation, and now in the following months we will implement it, because now open land use is part of many European projects, and we deal with many thematic data. So this will be systematized, and all this pseudocode will be put in real application. So thank you for your attention.
Thank you, Dima. Thank you very much. A very quick question then to Dimitri from the jury. Well, thank you very much, Dimitri.
Thank you everyone for attention. And
yeah, and now we are starting on a series of 3 of the citizen science projects challenges. We have 4, so the last one will be actually the very last one you will learn about. So Valantis, you are going to be presenting 2, 3, 2.5. I think Michael will be sharing the challenge number 8. So we start with number 6, which is integrating Inspire citizen science and Earth observation authentication systems. Are you ready? Yes.
Thank you, Bente.
Thank you.
Okay, so my name is Valantis Tiakos. I'm from the Institute of Communication and Computer System, located in Athens, Greece. I'm going to start with this challenge, number 6, aiming to integrate Inspire with citizen science and the Earth observation authentication systems. So next slide, please. So basically, the overall goal and aim is to allow users to enhance their geospatial or enable Inspire-enabled web-based applications, so as to be able to connect with either citizen science or Earth observation data. Okay, and so the goal is to improve accessibility to protected resources while also enabling their direct communication and utilization by third-party applications. So next slide, please. Okay, so the activities reside in the infrastructure already developed in the context of EU-funded projects. For instance, in the context of this hackathon, we will rely on citizen observatories, information systems that are used to collect valuable information and improve existing environmental monitoring methods. Particularly the identity access management system implemented in the context of SENT Citizens Observatory was utilized. So this identity access management has been originally implemented to secure the resources collected in the context of SENT projects from unauthorized access. We have a security mechanism that is being implemented with a key clock instance and holds the database of the users in the groups. And also it offers user interfaces for changing its configuration or creating new users. So next slide, please. So the main activities and the results and the main activities in this hackathon were that we have different front-end JavaScript applications that were able to connect with the SENT platform and identity access management by applying implicit grant type of authorization according to OAuth protocol. This happens because the client-side applications cannot guarantee the client secret confidentiality, which is essential for the OAuth flows. And so following an access token, and also following the user login, an access token is issued immediately, allowing the user to access and use the protected resources and operations. In addition, the access token issued from the authorization server, there is an ID token, and this is in the form of a JSON web token that is signed with the primary key of the issuer of the SENT identity access management, and it can be parsed by the third-party application. And also in this, we can see that there's also another handful properties that are interested for the third-party application, like the unique identifier for the user, the identifier for the server, for the identifier for the client, and so on. So next slide, please. Okay, and here it is the basic, let's say, workflow that has been followed by the different applications to be able to collect, to authenticate and access a protected citizen science resource. So the first step basically involves the registration of the application to the SENT identity access management system. So during this process, we define different parameters like the client ID, that is a publicly exposed string that can be used by the service API to identify the application. The redirect URI, that is the location where the service will redirect the user after they authorize or deny, the application. And then there is an interaction of the user, as you can see here, that with the web browser choosing to log in, upon which the client generates and sends a login request to authorization server. And the request is sent in the form of a HTTP request, and the information is sent as a URL query parameters, including also the information they mentioned previously, the client ID, the redirect URI, the scope, and such values. And in what follows, the authorization server checks the request, and if it is valid, it presents to the user the login form. The user insets his credentials, and following the conclusion of the process, the access and ID tokens are verified. In particular, what we check in this step is that the JSON web token that I mentioned, if it is well formed, we check the signature, if it validates the standard claims and the permission of the application. And in case of successful successful verification, the protected resource is offered to the third-party client application. Next slide. So here it is an example, let's say, of an application managed to collect some of the citizen science resources from the Nibet Delta and being able to integrate it in a web map layer. And next slide, please. Yes, and the conclusion, the main benefits from this is that we aim to tackle the fragmentation of the citizen science project resources that often are not freely available and need special treatment in order to be accessible. And the exploitation of these resources when having different systems across multiple organizations, projects, trusting, connecting to a single third-party identity provider, so trying to establish a single sign-on or further improving in the future to a federation. and the use of OAuth 2, that is an open industry standard protocol for authorization that can ensure the interoperability and scalability between the various related applications and scenarios. And also this is important also for future development and applications. Thank you very much.
Thank you very much, Valantis. We will take some questions from the jury before we go to the next citizen science project. So jury members, any questions? This is a general challenge, I guess, not only for citizen science areas. Stefano, Jitka, and Alexander. No question?
Sorry, Stefan speaking. Why use OpenID? Why? It's not better other library to integrate more easily the application?
We didn't use this in this case. Perhaps it was shown in a slide. We relied on OAuth 2, and we didn't use OpenID. But you know, I referenced this there because it is one of of the application of the libraries, or of the technologies that are being used by citizen observatories. So in the context of this case, of this integration, let's say of this architecture that we try to expose, and trying to have different people connected, different applications connected to the send identity access management. Only OAuth 2 was needed, and the scenarios was based on this.
Okay, thank you. And then we are ready for your next challenge, which is number 7, establish the connection of Citizens Observatories resources with a central catalog.
Okay, so it's me again.
Yes.
Okay, so continuing, also in what mentioned before, citizen observatories constitute community-based environmental monitoring and information systems that invite individuals to share observations via mobile phone or over the web. So next slide, please. So in this sense, there are different projects funded under the Horizon 2020 program. Citizen observatories like GROW, Ground Truth, Lancet, and Send, and also other past projects. But apart from them, there are also other initiatives that do exist, collecting and contributing with data of environmental interest. And we let's say have a rather fragmented landscape of these related activities. So the main goal of the challenge was to enable the integration of data sets provided by citizen observatories and other related projects and initiatives with a centralized catalog provided by the NextGeos project, so as an approach to connect citizen science into the geos. Next slide, please. Okay, so as I mentioned, in citizen observatories, during this process, there's a variety of smart and innovative applications that have been implemented, enabling citizens to be engaged with environmental monitoring during their everyday activities using mobile devices and low-cost sensors, coupled with data analytics, quality assurance techniques, and data management principles, so as to improve environmental decision making. This involves a variety of data sets, thematically wise, like land cover, land use, soil parameters, air quality measurements, phenological observations, and also outputs with reference to disaster resilience. And so, as I mentioned, and this is connected also to the Horizon that we observe project, this is a CSA and has established different communities of practice. One of them aims to facilitate and promote access to citizen science resources, among other things. So the idea about this was, next slide please, to demonstrate such an integration, the connection of such a project with the NextGeos catalog. So the main activities that took place in this sense are the analysis of existing infrastructure and endpoints that enable machine-to-machine access to resources. Also, there was, in this process also, there was an assessment of querying and capabilities provided the provided endpoints, this kind of information in the metadata and so on. Also, a template was compiled that were allowed us to document resources provided from community-based environmental monitoring citizen science projects. And it was based on Dublin Core model. And finally, there was an implementation and testing and deployment of a data harvester for sent citizen science data that constitute a prototype for the ingestion of citizen science resources into meaning metadata into a centralized catalog. And also this implementation is available in GitHub. So next slide, please. So here it is mainly the output interface in the NextGeos catalog project, where the Send Citizen Observatory is listed as one of the data providers. So the NextGeos provides a collection about various projects of environmental monitoring, and there also we have Send having different datasets concerning about land cover, land use, and about water velocity in river networks, soil moisture and temperature, water level measurements, and so on. Next slide.
1 minute left.
Yeah, so to be quick, so all the datasets are organized by collection and can be found there. So more than 60,000 datasets are cataloged containing metadata and resource links to download the corresponding file associated to each dataset. Next slide, please. So if you check, if you click on a file, you can see the details about the resource. About for one image metadata and how this can be downloaded in which format, because the catalog stores metadata information, but there is also a way to access the data being provided. And next slide, please. And also there is a possibility to search for the same collections in the NextGeos catalog via open search interface and filter them by collection, time interval, and so on. Here it is an example for a query involving image and time interval. And last slide, please. Yeah, the main benefits from this exercise are to maximize the value of citizen science data by facilitating discoverability and usability along with other such resources, to act as a deterring factor towards creating silos of resources between the different initiatives through their promotion from the central catalog, the promotion of open standards and solutions for data sharing, and the facilitating the uptake of citizen science resources as part of SDGs monitoring and the application and their utilization in the context of monitoring relevant indicators along with other existing citizen observatories data and data observation data. Thank you very much.
Thank you, Valantis. And I ask again the jury members.
Jitka here.
Yes.
Valantis were presenting there was kind of a proof of a concept, right? Is there already such a catalog established where you can see all the citizen science data, and who is responsible for such a catalog? Is it or who?
Yeah, so if I understand well your question, you were asking if there is such an infrastructure that is able to host, you know, all this information about citizen science data and provide them via catalog or also data sharing approaches, something like this, you mean?
Yes. And if there is such a catalog in place already, who is, you know, responsible for the?
No, currently there is no such catalog in place. Okay, so this is also one of the benefits of this activity, trying to demonstrate that by applying such a data harvesting methodology about, you know, data sets like the ones collected in Send that involve different thematics, this can be applied also in other principles, in other projects, in other thematics, or in other infrastructures, focusing on the same logic. Okay, so being able to connect endpoints or infrastructures made available from citizen science activities and present them in a centralized catalog, and subsequently through this through NextGeos catalog, this also can be made available into the Geos portal also as entries, being part also of the wider community of resources for environmental monitoring.
Okay,
yeah.
thank you.
Jitka, I'll put on my NextGeos hat And I think that there is actually a existing catalog of data where this is the scent data that was presented here is actually cataloged in a operational catalog, the NextGeos catalog.
Okay.
So, but if that was your question, but so the proof of concept, as I understood you, Valantis, is just you have used one data set or, a part of the citizen science data from scent to demonstrate how that can be cataloged. But the catalog is real and running, and it's NextGeos. And NextGeos is a Horizon 2020 project, is one of the sponsors of this hackathon and several other hackathons as well. And it's funded by the European Commission, but it will, after the end of the project, the key partners have decided to maintain this catalog also beyond the project period. So I don't know if that.
Yeah, thank you for the information. That's really. I'll check.
Yeah. Okay. Okay, so I see that I answered the question for Alexander. Is there, I think we can, well, any other questions? Stefano, did you have a question as well? No.
No.
No. Okay. We move on, Valantis. Keep on keeping on, huh? The next, the next challenge that you have been working on is improve the interoperability between methods for sharing in situ and citizen-sourced data. And will you be sharing this with this presentation with Michael, or how is it?
Yes.
Okay.
I will start giving some introduction, a small introduction, because I would like to speak more a lot, about SensorThings API or the activities. I will just set the scene, and then Michael will present some of the activities that took place.
Yes. Thank you.
Okay.
Go ahead.
Okay. So next slide. Okay. So the goal of this challenge is to make available, data sets provided by citizen observatory or other relevant initiatives in an interoperable way and ensure standardized access to such resources. So for this, due to, as we will explain later on, the focus was in the design and implementation of data translators that will facilitate such conversions from various data models that are not always according to a standardized format according to the OGC SensorThings API compatible schemas, and also to integrate such datasets of environmental monitoring by the utilization of spatial data translators, and also we'll see later on what we mean by this. So next slide. Yeah, okay, so a bit of the background about this. And also, as I mentioned, the outcome of the challenge is the development of an aligned methodology, more or less inspired by the Inspire harmonization process, and the implementation of data translators and connectors that will facilitate the conversion of resources to the SensorThings API. So why SensorThings API? Because, and particularly for citizen science data, because based on our analysis, according to other standards coming from the OGC, it provides more flexibility and it can ensure interoperability, facilitate modeling of both crowdsourced and in situ measurements. Also, it allows the efficient modeling of moving sensors, as we like to call them, people having mobile devices and capturing information in the context of different campaigns and IoT devices. Allows monitoring of heterogeneous data sources, and support HTTP post, delete, put, and patch request, and the creation of and update of deletion of identities. Next slide, please. So in the context of this activity, an OGC SensorThings API implementation was made available, originally coming from the Sen Citizen Observatory. So this is implemented as a standalone Tomcat application using the Jersey REST Web Services framework, and supports all requests according to the standards in terms of filtering. So a root URI was made available to the participants of the challenge, so as to be used, and different GET requests were created so as to facilitate the uptake of such resources. I will not say much about this, so next slide, please. And Michael, the floor is yours.
Thank you, Valentis. Hello. I would like to present you one let's say exercise we made during this challenge. It was a challenge of mapping between two data models, one of OGC sensor things standard, and the second one was our internal SenseLog data model. When SenseLog data model is based on ISO observation and measurement standard, so the core of the model can be or should be mapped easier for this between these data models. We realized that even we have different names of entities between models, the content of these entities is more or less similar. We could use 70% of attributes in one-to-one relation. Another 20% of attributes can be filled in by calculations or by some combinations of different attributes. And the remaining 10% should be added from outside by user or by the operator. So
That's
on
great.
the next slide, please. For, let's say, exchanging data between Sensor Things API instance and SenseLog instance, we have designed a SenseLog connector that is component of SenseLog that is translating between external APIs and between internal SenseLog API. So this component is able to push or pull data from or to external data storage, and it's improving interoperability of SenseLog component. So next slide, please. In the next future, we would like to fully implement components based on OGC Sensor Things API specification to have fully integrate communication interface. And we would like to final or finish design and implementation of VGI module for SenseLog to be able to store observation with multimedia content and different attributes. So last slide, please. So the conclusion is that we try to map between two sensor data systems. We try to integrate example data set, and we try to contribute in the integration and utilization of citizen science data with monitoring and environmental data. So it was the result of our challenge. So thank you.
Thank you both, Valentis and Michael, for this presentation. And again, over to the jury. Do you have any questions for the presenters?
I would have one.
Go ahead.
Thank you. Thanks for the presentation. I was wondering, when you did the mapping, did you experience any limitations on the Sensor Things API data modeling end? Because in the last version of the standard, it is possible to extend it. Did you have to do that, or were you completely happy with the model out of the box as provided by the OGC? Thanks.
Thank you, Alexander, for the question. From my point of view, as I'm the main developer of SenseLog data model, so I'm trying to, let's say, mapping this data models. Sensor Things API is, let's say, very useful in general cases for some special cases. As in SenseLog, we have, let's say, user hierarchy or a unit or measuring unit hierarchy. This is not possible to do it in Sensor Things API. So maybe this can be space for some extension. And let's say the data types for Sensor Things API for observation, it's at this moment very, very useful. So mainly additional extension can be possible.
Thank you. Thanks.
Thank you. And we are moving on to the next presentation, which will be more of an ideathon. and that's the EO for Agri, which is a Horizon 2020 project. One of the supporter of this hackathon. And Carol, are you ready to present?
Yes, I am ready. I am here, Bente.
Yes, great.
Okay, a little on the introduction. Hanka, can we go to second slide? As the EO for Agri is the study of European Commission, and the goal is to make recommendation for future satellite mission, but also for the methods and needs of agriculture sector, and also in the relation with the investment to DEAS, how to use this in the future. Next. Generally, this project was a little influenced by this COVID-19 situation, because there were important part expected discussion with a group of stakeholders, which is now a little complicated. So we decided to use the hackathons as some space where we can collect the ideas for our recommendation. Next. And there were, with Dubrovnik hackathon, there were parallel other hackathon in Kampala, which was more focused on Africa, but the task for EO for Agri is also to look on food safety and food security. So we use both this hackathon for collection of information, and there were three things what we done. One was the questionnaire, then communication with the community. It was mainly in Africa for Smart AfriHub, and what is the most important for me is the analysis of other challenges. So what we are doing, you heard a number of things related to Earth observation, and this is also important input. Next. So about the questionnaire, it is here. I think that it till now is running. Next. Hackathons help us to increase the number of answers. I took only one from the analysis, and what I see as the most important message from the questionnaire, that people will be happy to have much more precise or better resolution of the data. You can see that 32% wish to have data with resolution 1 meter and higher, and for other 40 will be good to have between 1 and 5 meters. So there is something what is further thinking about the future mission. Of course, something is already covered by commercial satellite, but seems that for agriculture, this higher resolution will be very important for the future. Next. As I mentioned, we had the big communication in Africa using this fully Smart AfriHub, and what was the main thing that in the relation with agriculture, probably the most people minimally in Africa, but we recognize also in Europe, is the most interesting about the climatic changes and influence of the climate on agriculture production. And there is a very strong need to combine climatic data, including data from meteorological sensors, with terrestrial data, and to be able to help adapt farming sector on these climatic changes. Next. And I try to put also some very interesting things what was done as the challenges. One challenge was on desert locust. It is now or was this year a big problem in Africa with the insects destroying all things. Generally, it was very new application of Earth observation. Next. And you can see the result of analysis, and seems that there is some new type of application or analysis which could be useful, and which can help very much to the farmers.
Last minute, Carol.
Okay, next. Other things are climatic data. Next. And also you heard about these topics of artificial intelligence. Next. Next. What is now the next step? That we will prepare some gap analysis document for European Commission and white paper. Next. And from the conclusion, this main things from the hackathon is that we need to have a resolution better than 10 meters. Sentinel-1 is something what has to be focused and tested much more for the future. There are new domain where Earth observation could be applied, and also we need a more complex workflow. Not only could be simple classification, but it has to be put into complex workflow, and we need also integration with non-EO data. Yes, it is important not to try to work only with Earth observation data, but integration with non-EO data is something what is very important for future. And if we were thinking about DIAS or other platform, we need to be able to integrate this data. It's all from my side.
Thank you very much, Karol. And since you were talking about Earth observation data, I just wanted to clarify what we mean by Earth observation data. Earth observation data comprise both in situ, so ground truth data, and space-based data. Just in some communities, Earth observations are only equivalent to space, but Earth observation in general, in GEO, the group on Earth observation, is actually all types of Earth observations in situ and space and everything in between. So
But I agree with you. The problem is that till now, DIASIS is not thinking too much about in situ data. Yes, probably also in relation with previous challenges, it could be important to promote to DIASIS integrated this type of the data.
Yeah, and I think, well, the DIAS is yes, but the Copernicus, the different Copernicus the platforms are actually having Earth observations. I saw that the Environmental Agency of Europe was here. Stefan was here, but I don't see him now. But the European Environmental Agency is responsible for the in situ component on Copernicus, at least. And we do, as you know, we do have also in situ data cataloged on NextGeo. So there are other how should I say, platforms where you have both all of these types of data available. But the point is, Earth observation is more than just a space-based. Question for Karol for the jury. No questions? No. Okay. So we move on. Thank you very much, Karol. As you can tell, we have many different types of problems, level of problems or challenges that we address, to very technical to more on an idea level. Now we are ready to learn about assessing phenological events in agriculture based on Copernicus data. We were talking about Copernicus. And Cosmin, are you with us? I think you will share your screen yourself, not Hanka, because you have a video to show us. Or
yes.
Animation. Yes.
Yeah. Hello, everybody. Good afternoon. I think it's a more correct way to do it. I will share my presentation. I'm going to present you very shortly this challenge 10 about assessing phenological events in agriculture based on Copernicus data. This presentation is made with my colleagues Yannick and Vivian from Walloon Agricultural Research Center, and Guido from Food Security Unit in GRC, and Sophie Bontemps from University Catholic of Leuven. Very shortly about the phenology, what is, we know that is a study of periodic plant and animal life cycle events and how these are influenced by seasonal and interannual variation in climate. The first time was introduced in the 19th century in Belgium, and you know all about which kind of phenology, its emergence of leaves, first flight of butterflies, first appearance of migratory birds, or the date of leaf coloring and fall in deciduous trees. What we can do with this phenology? It's first, there are different applications, but just to give you some use of phenology as in general life, if I can see like that, it's maybe to quantify the ongoing climate change, or to predict some human allergy and mosquito, or to manage invasive species and forest pests, and maybe to know much about carbon cycling at ecosystem level. But now I'd like to go more in depth in agriculture and what we can do in agriculture having this information about the phenology. It's, for example, to optimize when we have to plant, to fertilize, and to apply treatments, and maybe to harvest crop. We can see in the left part crop growing season and the use of nitrogen. In the right part, we can see two fields of potato near one of the other with a really different phenological stages. It's really different. And this information can help us to optimize the harvest operation over a territory. It's an example for iPod project. When we can see where is the homogeneous field in terms of phenology. And it's also really important for us, we are more interested in this part, for yield estimation and forecast provided by crop grow monitoring system. This phenological information, it's important to be used in crop grow modeling because can help us to better fit the model and to have a correct estimation of yield at regional or national scale. The idea is that up to now, it's very often used temporal evolution of LI time series or NDVI, vegetation indexes, but all this information comes from optical data. This information, it's really nice to have it, and I can say so easy to be used when optical data are available. But the problem is when the optical data are missing. And just an example here, during 1.5 months, we don't have any optical acquisition due to the cloud cover. And in this case, we have to go to have any information about phenology. And maybe a solution could be the use of Sentinel-1 SAR data, which is active sensor, and it's independent of the weather and the daylight.
Last minute.
Yeah, thanks. This is different advantages to use Sentinel-1 data. It could have an idea about that processing could be more difficult, complex, but there are different solutions today, especially to use the cloud computing as Google Earth Engine, the DIAS, and Amazon. We have to have expertise in this field, so a large expertise. And to go more in depth, we can just present you two examples of two open source freewares, Send2Agri and Send4Cap, made by European Space Agency, and an example of Belcam in Belgium, an interactive platform for farmers. And today, if we have optical data we're happy with, but the idea is to use also Sentinel-1 coherence and backscattering coefficients, meteo information, and to use algorithms and maybe new models like the water cloud model to have information to be used in this phenological event monitoring. And for sure, we have not forgot this Copernicus land layers about which already will be ready, I think, in the productivity and phenology high resolution layer. Thank you very much for your attention.
Thank you very much, Cosmin. So, the jury, do you have any questions? No, I don't hear any. Then we move on to number 11, which is a special one, the Copernicus and land parcel information systems. And it's going to be me who is doing the presentation on behalf of Gerhard Chibnig from EOX. He could not be here. So this is a very special, just for the jury members and everyone, this is a very special challenge because we are wanting to engage with the payment agencies. So next one. So we had a webinar where we invited the payment agencies in particular and everybody who is interested in the technical part of the problem of combining Copernicus data with this LPIS for short, and using this new technology, data cubes technology. Just CAP is the Common Agriculture Policy, and PAs in the future here is the paying agencies. I will go very quickly through this. Next one. So the topics that we addressed in this specific webinar was to present a result of a survey where we ask what the need is. Well, it was a wide questionnaire for the payment agency and by one of the partners of EO for Agri, the Lithuanian payment agency. And so we focused on one of or a subset of the projects, namely how they saw the possibility of using Copernicus data and combine that with LPIS and do analysis on using data cubes. Then we went into more technical details to look at signals and markers as a service for them. And then we went down to the data cube in the two more technical presentations. Next one. These are the experts that we got to engage, and they have the payment agencies and several different experts from Brockman, a consult from Synergize. They are running, among others, the Sentinel Hub, and also an expert in EOX. Next, please. So the result I would like to, I'm very happy to announce that we actually engaged quite a bit of the payment agencies. We were very excited about that. You know, we were curious if we would be able to engage them in this topic. And indeed we were. Next one. And it turns out that there are several who are using already Earth observations Copernicus data related to the CAP area monitoring, 62%, as you see. But there are also a considerable amount of individuals who are considering using that. And then the next, so that was the Copernicus, then the data cube technology. That was more divided. You see that there are some that knows about the data cubes, so 32%, and a few, 10% is actually was already using it, but quite a few were 48% would like to learn more about them. Okay, next. So we identified several needs for further exchange. So we had a very lively discussion in the chat, actually, of what would be interesting to learn more about. And that was addressing small partials issues and use of very high resolution satellite data. There's, Copernicus has limitations on resolution. And approaches for detection of mowing and grazing events. That was a topic that were extensively discussed in the chat. I will not go into the details here. And then, of course, LPIS data information and EX data interoperability project. So making this data interoperable. Okay, next.
Last minute.
Yes, and I finished. So thank you so much for the attention. It was a successful workshop, webinar. We managed to engage the payment agency communities. We were positively surprised that they were more eager to move forward and make use of both more data, Copernicus data, and new technology in their work in the payment agencies. So thank you very much. Yes.
Bente, I might have a very non-technical question. The payment agency.
You're breaking up, Jitka, a little bit. Can you repeat?
Sorry, I have a very non-technical question. What is a payment agency?
Okay, so the agricultural sector, they get subsidized by the government. It's a system. Basically, every country in Europe have that. And so the payment agency is actually the ones who are then paying out the subsidies to the farmers. And that is based on, for instance, if they have some issues with drought or whatever, they get compensated for that. So it's quite, so they need to know. So the payment agencies need to know exactly what is going on the farm. Yeah, so it's quite, there's a lot of economy in it, but it's also a little bit sensitive in terms of exactly for the economy of it.
Okay, thank you very much.
Yeah. Okay. Maybe Cosmin will like to complement my answer. I don't know.
Yeah, you're right. In fact, for each member state, there is a paying agency that they are responsible to receive the request for the subsidy, and at the same time to check if the subsidy go on the right direction.
Yes. Yes. Okay, so we are moving on to the last, I think, yes, and that's interchangeable map. Yet again, we return to citizen science, citizens' observations, interchangeable map compositions in support of collaborative spatial intelligence. It's it's hidden that this is for citizens, but Carol, I expect you are going to present this as well, or do you have somebody else?
I will do this, yeah.
Yes. Go ahead, Carol.
Okay, so I think you can see that a relatively big team who work about this, and can we go to next? There is a huge investment into the data. We have Copernicus. It was many times mentioned. A lot of data is collected. Next. As you can see, the different possibility. We have a huge number of portals, a huge number of information. There is massive investment into the data analysis. Next. But what I would like to share, on one side, we are sharing a lot of data, but the data are very often not useful for user community. And there is one more thing, yes, if we are thinking about the knowledge about some result, till now all systems are, from my point of view, centralist. Yes, that you have some portal, you have some apps, and the information is available there. But what I see as important and future to improve usage of the data is to move more towards peer-to-peer data, not data, but knowledge sharing. And this is something what we are now working next. We are using the concept of map composition. It is not a very new concept. Initially, it was started with OGC, Web Map Context. It can know that this map composition concept was used on the Czech Inspire portal already 10 years ago. But we are trying now shift this concept really towards some peer-to-peer sharing. Next. So how we can, what is important that people will be able to share not only WMS or WFS or something what is possible, but there will be able to share thematic maps among different platforms. Next. And this can help to, in many areas, to make a decision better, more easy. Next. Here is something what we try, because this map concept was extended against OGC standard in HLS and HLS NG, but now we move to this more peer-to-peer working next. And here you can see the scheme. What is important on this scheme, that there is a small extension allowing to other clients read this JSON document, which is describing map composition. You will be very easy to, with current standards, share this map composition between different platforms, usually based on CSV communication protocol. You can share the information from the catalog, and you can also use the common standard or WFS, GeoJSON, or shapefile for sharing. Important is that all map composition which you are now able to use on some portal, you are able to use outside in QGIS application with some special plugin, and you are able, all what you will draw or what you will prepare or what you will have on your QGIS very easy again share with the people through the portal. This is one thing what was done, and I am happy to say that with this solution we are already now on the level TRL between TRL 7 and 8, and it is tested in many practical environments, and we see this as very important for the future. Next. So here you can see that there is again is standard communication is through standard security
Last
protocol.
minute, Karel.
Yeah, because we are able to go next. Next, one more. One more. What is important is second things. You are all working with the Google, and there is second challenge what we are working, and this is to be able to share the maps in the same way as the Google, as is done with Google Documents. So anybody is able to draw the maps, and immediately other people are able to use and work with these maps. This is very important for planners. You are expecting something, you need to discuss with the people now with the COVID period. If you are able to share this and work online with the maps, it is something new. Next. We implement the server side, and we are now testing the clients based again on open layers. Next. And we develop APIs. We develop APIs which is described and which will be soon published. And we have a first running demonstration. Next. And we are now testing this. It was initially done in open layers. We are now testing this as a part of AH layers, and we expected that this will be new way of citizen science or cooperation. These two things that people will be able interactively work and share the data and the maps. It is all from my side.
Thank you very much, Karel. And that ends all the 12.
Here is TRL 6, yes.
TRL 6, okay. Yes, thank you very much. That's 12 challenges that you just learned about. You saw the results. Now it is time for the jury to retire and for us others to stretch our legs a little bit. But so now in the next session, we will then announce the winners. And so wait for the results and from the jury. But in the Slido now, you will be able to pick your favorite challenge team result and let us know, because we will have the popular, the audience winner as well, to announce that as well. So you please, yes, can you then share Vlado, or is it Hanka who is sharing?
Yes, it's me sharing.
Yes, Vlado. So you can share the Slido.
Okay,
so that
the
people see.
first poll was already open, so just to see from where the people are. So it seems most are from Europe, but we have only 11 participants. So please, for the rest, if you can let us know where you're coming from.
Yeah, that would be That would be interesting.
Okay, the numbers are increasing.
Yes. So we have a timetable for this, and I have to say thank you, Thomas, for your reliable reminders of time. We are pretty close to be on time. Just a couple of minutes delay, which is great. I think that yes. Let me see. Yeah. So what will happen now is that during retire, you will be able to vote for your favorite team, and we will have some, an award ceremony, celebrate the results. But I also want to underline that this is not the regular competition. It's more like a friendly family playing time, but we do have some winners. The top 3 will be announced, and what the reward for them will be to get some more airtime. We will support publication, because that's for many of these participants, having the results published is something they can benefit from professionally. And secondly, we also increase the community of people working on these exciting topics that we are doing in the Inspire community. And also we are maintaining that there will be a next Inspire Hackathon, and so we are building up for the continuation of some of these challenges. So you will learn more about that after the break. I will think this will take 5 to 10 minutes. So stretch your legs, and Vlado, you will share, right?
Yeah, I will just start now
Yeah.
the second poll. So for
Yeah.
this answer is clear. So all from you.
Okay. Thank you. I will support the jury.
Okay.
Yeah.
Good. So please use the opportunity also to say your word.
the jury has made its decision. It was it was very hard to identify the score, the top three, because there were so many good. That was the problem. Okay. So Vlado, I see that we have a public, the audience.
Yeah, results are here.
Yeah.
I don't know if you want to comment it or not, or later.
Yeah, I know we can start with that as the jury is collecting themselves and coming into this room again. I think we can we identify the, what do you call it, the popular score or the population score. I don't know, I'm not for sure in English, but it looks like it's a number one, actually. They're using the Sentinel-1 data on Internet of Things technology for analysis of soil moisture. And that was Jana, the very first one, who presented that. So that's number one. Number two, you get it. There's the second one is using ML for detection of land use objects. And I think that was number two. The challenge number two came in second. And the third one, the traffic modeling, well, there's a division between traffic modeling from web browser use case of, and excuse my Czech, Františkovi Lesne, maybe, okay. And then the third, the shared third place is assessing phenological events in agriculture based on Copernicus data. So great, interesting. We will announce this result also when we are reporting from this event. So thank you very much for participating. Now we are ready to do the jury, to listen to the jury. So I don't know, I mean, we are so happy to be at this point. We started this virtual hackathon in March, actually, so it's been ongoing for quite some time. And finally, we are here and part of the Inspire conference with the results. But the results is also just the beginning of the next steps. This is in the spirit of the Inspire hackathons. And well, maybe before we give the floor to the jury, Thomas, are you, maybe you are, Plan for All is organizing these hackathons, and Thomas, you are the chair of leading the organization Plan for All. Do you have any comments? I will give the floor to you before we reveal the result.
Thank you, Bente. Well, it was a great pleasure to see all the presentations and so many teams presented. And I'm sort of glad that the jury finds it difficult to decide which one is the best. And yeah, let's go ahead and announce the winners.
Yes, and we will publish, of course, these results on the planforall.eu webpage. This is part of the reward for being a member and participating in our Inspire hackathons. Okay, jury, the excitement. We start with number 3. The floor is yours. Alexander, I believe you will be the voice of the jury.
I'm just the messenger. After our jury, after a tough discussion, we consider that all the teams are winners, actually. So congratulations to all for the good ideas. We hope that the results will be sustained and there will be future evolution, because there are really brilliant ideas all across. So well done, teams. But this is not how competitions and hackathons work. So we really need to announce. So number 3 for us, so the bronze medal goes to challenge number 2, which is HANA and machine learning for the detection of land use objects. And this a round of applause for HANA and her team. Well done.
Thank you.
Fantastic. Okay, Let's move on. In the interest of time, I see we just move on to the second place.
Me again. So that one goes to challenge number 7, establishing the connection of citizen observatories resources with the central catalog. Well done.
Yay! Are you here still?
Yes, thank you. Thank you very much for this. On behalf of the team.
Thank you. Thank you for the clever idea and excellent implementation.
Thank you.
And the winner, number 1, except for all winners, the extra winner is Alexander.
And the winner is challenge number 4, traffic modeling from a web browser, the use case of Františkovi Lázně.
Yay!
Well done.
Danny, are you here still? Maybe not.
I am here. I am here. Can you hear me?
Yes.
Thank you. Thank you. Thank you very much. Thank you to the jury. And thank you to all the people that participated on our side, especially the students.
Excellent. So with that, I think we are ready to conclude this event. Let me see how we are. The last words and thanks. This is what it says on my program. We are a little bit over time, but we were allowed since we are in the lunchtime. Karen and Vlado told us. Thank you so much for staying with us. Thank you so much, all the participants. Thank you so much, the jury. And I can only recommend that you join us in the next version of the Inspire Hackathon. This is not an event. This is the words of Karel Harvat. He's actually, we count him as the godfather of the Inspire Hackathon, and he has been participating this year. The Inspire Hackathon is not an event, it's a process. So there will be several more opportunities for you, both if you participated now and if this is the first time you see or learn about the Inspire Hackathon. There will be future hackathons. You can follow us on Twitter, Plan for All, or you can follow us on Facebook as well, and to find more information. And we thank you so much to all the supporters. We have several organizations and EU projects supporting this, and a big thank you to the Inspire conference for working with us with this Inspire Hackathon. The results, by the way, the results of this hackathon, so the top 3 and the popular prize will be announced in the final event. I think Hugo de Groot will be doing doing us his honor to mention the results of the Inspire Hackathon. So be sure to attend that event also online, which will be, Vlado, on Friday, is it? At what time?
Yes, at 4 p.m.
At 4 p.m.
Yeah.
Yeah. Just before your beer or your wine or whatever you start the weekend with. Okay. For me, thank you. That's it. Any other final words? Thank you. Big thank you to the jury, of course. Excellent work.
I would like to give thanks to you, Bente and Hanka, for the organization, because it was tremendous work, as usual, done by you and Hanka. So, yeah, thank you very much for that.
A pleasure. This is great fun. Right, Hanka? Hanka is...
Yeah, I was muted again.
Yes.
It was our pleasure, Thomas.
Yes, yes. Okay.
Thank
See
you.
you soon
Goodbye.
again. Bye-bye, and thank for now.
Bye-bye. In the next hackathon. Bye-bye.
Yes.
Bye.
Bye. Thank you.